What is SNMP in network monitoring tools? SNMP allows a network management system, which is basically a piece of software running on the server, to collect data on a managed device and modify device parameters. And we have read-only and read and write access to managed device. It uses Managed Information Base or MIB to determine what parameter to gather. So let's talk about some of the key terms and concepts. Managed device. That's the router, server, switch, or IoT or Internet of Things devices. And there is a great number of devices that are SNMP manageable. And we are surrounded by all SNMP managed devices nowadays, even your home router and so on. Basically, a managed device and SNMP is anything that speaks SNMP protocol. The next is SNMP agent, which runs on a managed device. It's basically a small piece of software that talks SNMP on Windows and Linux boxes. It's a service that you install on industrial equipment. It's probably part of SOC system, something like server system, to talk to the system on backend and translate that into SNMP data for a computer system to collect. Next is a network management station, which is quite simply the device that gathers all business SNMP data and collects it and displays it so that you can look at it and make business decision on it. We'll install a network management station, and simply if you don't have some type of network management station, you are not going to be able to make good sense of SNMP data that you get it. And finally is Managed Information Base, or MIB, that basically translates the raw SNMP data with its object IDs into something that the management station can understand. There are several industry standard management information bases, but if you're going to get a detailed information out of a vendor, a specific piece of hardware, you're almost certainly going to have to install a separate management information base. And in this course, I'm going to explain MIB protocol and show you how we can use it in our network management station. And lastly, don't worry, SNMP is basic and pretty simple protocol that you can master it in this course. So now that we've get an overview of SNMP, let's take a few minutes and talk more about the differences between the three versions of SNMP. First, we'll start off with SNMP v1. It was introduced in 1988 with RFCs 1065 to 1068. You can do a search for RFCs if you like to know more, and we're not going to talk about them in this course. It was superseded with 1990, the version of SNMP that was introduced in 1988. With RFCs 1155 till 1157. SNMP v1 is non-secure and it has a very poor security. Basically, there is no security built into the SNMP protocol itself. And it requires external security such as TLS or an IPsec tunnel. The reason for the poor security is that SNMP v1 basically transmits its community name in clear text. The community name is basically a password. It is the word or phrase that authenticates a network management station to the network device. And hackers or anyone can read or write to your device in the network. And there are some basics ways to secure SNMP on your network. And we'll go over those security models in this course. SNMP v2 was introduced in 1441 and 1452. It adds functionality to the SNMP v1 protocol, specifically the get bulk request command. It also added a security model because again SNMP v1 is very insecure. And that security model really wasn't accepted by the community at large, like IPv6 hasn't been accepted by the community at large. And then SNMP 2VC came out with RFCs 1901 to 1908, which was the community edition. Basically, it takes added functionality of 64-bit counters in get bulk request command without all that passkey security, so it still uses the community string like SNMP v1, and again it's non-secure, and it's probably the most uses SNMP in worldwide for networks. And modern Windows actually do not install SNMP by default. You have to install it manually, and they prefer you to use WMI for management, which I'm going to demonstrate and show you how you can use WMI in Windows. So you might ask, they are as the same in function, SNMP v1 and v2. How interoperable are they? The answer is they're not. They're completely incompatible. Mainly because the UDP headers different between v1 and v2. And the PDU or protocol data unit format is different as well. There are of course some different SNMP operations that 2VC support that SNMP v1 does not, and that also another level of incompatibility. So there are a couple of ways to work around this. The first, the proxy agent, then translate the SNMP v1 and send it to older devices. Or more commonly, you have a network management system that just supports both versions, and you have to tell the network management station to support a specified device in network for v1 and v2 version, so the management station knows how to talk to those devices. And lastly, we move on to SNMP v3. SNMP v3 is the newest of the protocol, defined in RFCs 3411 to 3418. The main differences between SNMP v1 and SNMP v3 is the SNMP v3 introduced a very strong security model. It encrypts the community and requires identity verification from both the security and receiving station. And it also has a framework for a user-based security model, so you can get away from community string at all and just have a username and password defined on the device. Other than security model, is functionally equivalent to SNMP v2 or v2c. We're not getting any added functionality with SNMP v3 other than the security model that brings inherent of the protocol. So now that we've talked a little bit about the different SNMP version, let's talk a bit about managing network devices in details. There are two methods of using SNMP from a network management station, and there is SNMP get and the SNMP put. The SNMP get, as it is clear, gets information from the managed device. It uses MIB to determine what object ID or OID to use, and it uses read-only access to get these information. The SNMP put allows you to put or change information on the device. It requires a read and write community string access, and this change can be overriding from changing device name and change and override the configuration and rebooting the device, like Cisco router. As we discussed earlier and we talked about SNMP v1 and v2c, the read-only and read and write community string are just that. They are sent plain text over the wire on the network, and you really have to be cautious using these two versions. And you should have to consider locking down your management station and your managed agent. That can help you to prevent malicious access to your device. Lastly, we'll talk about the differences between SNMP trap versus SNMP polling. So polling is kind of what we have been talking about this whole time. We have a management station and we have servers down here in the left. Basically, a management station sends a request to the device and the device replies back with information that was requested. And it may do this once a minute, once every 5 minutes. And here in the right, SNMP trap is pretty much the opposite. You have management devices and network devices down here like servers, routers, station, and etc. And some things happen on these devices. Someone modified the configuration or changed the interface name. You can tell the device to send the trap back to the SNMP management station, where you can then get alerts or notification for someone done the changes over the network devices. In production network, you're going to see 95% polling and devices that also send traps, and again, those are more infrastructure type of network device, things like Cisco routers, HPE servers, IBM stations, and so on. Is it still a good idea to have SNMP get every so often to pull the device and say, hey, you're still there, is everything still good with you? Otherwise, you might have a device goes offline and you never get a trap and you never know about it until someone asking about it. Hi, I hope you're doing well, and in this short video I want to apologize for my accent. As you can see, I do have an accent, and sorry for that inconvenience. But I promise as you go along the courses and watch the first or second section, you will get used to my accent. And of course, you'll enjoy my practical courses, which you can apply them for the real production environment. Again, sorry for my accent. So if you like my courses, I would appreciate it to give a good review and comment. Thanks to watch this video. Now we're going to move on and talk more about SNMP action on wire or packets. When you have a network management system polling a device using SNMP polling, like we discussed in previous lesson, SNMP polling uses UDP, which is the connectionless IP protocol. Network management protocol uses a connectionless transport, and when you look at it in details, TCP has three-way handshake, and you have got to do acknowledgement for each packet, sends and receive. And there is a lot more overhead with TCP protocol over UDP. UDP just kind of puts on the wire, then gets dropped if nothing found it. Specifically used in streaming video and audio like voice over IP and video conferencing. But when you're doing SNMP polling, you don't necessarily need all the overhead the TCP brings to the table, because all of that overhead might not be a problem if you're polling 5 or 10 or 15 devices. But if you're doing SNMP polling for a few hundred devices, you can very quickly bog down your management server with all of the TCP traffic. Here is the UDP packet. The source port is any port. Usually it's random, it's one of the high random ports. The destination port is 161. Now you can encrypt SNMP using TLS or datagram TLS or DTLS. And in that case, the destination port would be 10161. For SNMP notification, also known as SNMP traps and SNMP version 1, it also uses UDP for all the same reasons we talked about in the last slide. And the source port from the managed device is 162, and the destination port is usually any random high port. And for security, you can use TLS or DTLS, and it uses 10162. Now let's talk about object identifier. The actual technical definition of the object identifier that you can see it in the screen. It's an extensively used identification mechanism developed by ITUT and ISO IEC for naming any type of object, concept, or things with the globally unambiguous name which requires a persistence name. So let's explain it more. Object identifier uses ITUT X60 standard. It calls the OID standard if you like to look it up. Basically, object identifier and the word of SNMP define a logical entry for SNMP data. And it has three structures that you will see it in some of upcoming slides. And the very first number and the OIDs determines which organization controls all of the subsequent downstream items. So 0 is the ITUT, 1 is ISO, which all the SNMP OIDs start with 1. And actually it starts with the series of numbers that always as the same, which we will see it in a moment. And 2 is a joint collaboration, if you will, between the ISO and the ITUT. So this slide gives you an example of what an OID looks like. And like we discussed, notice that it starts with the very top, which is ISO, which is OID 1, and proceeds down on 3. Down at the bottom, we can see 13614199913, which is translated to ISO identifier organization DoD Internet Private Enterprise, Cisco System, Cisco Management, and Cisco Environmental Monitoring MIP. Now for our purpose, all of the OIDs, we're going to start with 136141, which is the private enterprise section of the ISO MIB 3. Now obviously that's a lot of numbers to remember. You might be asking, how can I be expected to remember all of these numbers? Actually, you're not. That's where the management information base comes in. MIB are basically plain text files that tell a network management system what all the different OIDs inside that MIBs are for, how to use them, and what format they're in. For example, this is the Cisco Environmental Monitoring Temperature status value portion of the Cisco Environmental Monitoring MIB, and you will see the syntax is gauge 32. It is read off in degrees Celsius, and of course it's read only because you can't write the number of degrees in a router. And you will see towards the bottom that it actually names Cisco Environmental Monitoring Temperature status entry, and it has an entry of 3. Now MIB are formatted what's called ASA.1 notation, which again we're not to look it in depth ASA.1, but each entry builds on the previous entries. When we look at MIBs here in just a moment, we can tell that interface statistics. For example, we have entry for errors and discards and packets and frames, receive and sends, and so on. MIB are actually compiled into the network management system. Each one is different, but the process is usually where you put the MIBs in a certain directory and scans every time that starts up. You're not expected to remember all of the OIDs. Obviously, network management system has all of the built-in to it, and you don't need to look for it. It knows the path down to the individual interface or whatever values you're going to monitor. If you have a highly specialized device such as the control panel for a built-in size generator, you may have to look through the MIB and figure out what value you want to pull back from that device, so that you can set up a custom pool inside your network management system to pull just that MIB, because obviously you can't have everything in a network management system out of the box. And the good news is that as long as you can read the MIB or contact system support and ask them what OIDs to use to get a piece of specific information, you can add that into most every network management system. Most standard MIBs are included with network management system. Usually these are the ones from the ISO, which is things like the system name and the uptime and the operating system version. But also many large manufacturers comes with nearly every network management system such as Intel or Juniper or Cisco. And again, if you have a specialized device from even those manufacturers, you may still have to compile in a custom MIB, or perhaps there is more detailed information in their custom MIB than what comes with the network management system. So now that we've learned a basic of how SNMP works at the packet level and how it works at the protocol level, we're going to move on and configure SNMP on this model. We're going to install and configure SNMP on a Windows 2019 server, and we'll configure SNMP version 2 on Windows Server because Windows Server does not support version 3 of SNMP. And they recommend you to use WMI to monitor and manage their server, and it's really like SNMP, and you will see how to configure WMI later on Windows in this model. And we also install SNMP on Cisco devices and VMware ESXi and Linux operating system in this course. So here we are on a Windows Server 2019, and you can easily install Windows 2016 or 19 on VMware Player or Workstation or VirtualBox to practice this course. The first thing we're going to do is to install SNMP Server on Server Manager. So on Manage, we'll click Add Role and Features. Next. So this is screen for role, and we need the feature because SNMP is feature on Windows Server. And we'll scroll down to find SNMP service, which is here. Also we have SNMP WMI provider, and actually we'll click both of them, and we'll click on Next and Install. So as you can see, we successfully installed SNMP service through the Server Manager. So we'll hit close and we'll close server manager window here. So we'll type services.msc and we're looking for SNMP, which is SNMP service and SNMP trap. So we'll double click on SNMP service, and at the first we're going to configure security. So here in this box we should add community right here, which is read only, read and write, and read create. And actually this read create, it will help you to create new entries on the SNMP databases, but not actually overwriting the existing one. So we're going to say read only. Here we'll say lab.ro, which refers to read only, and again we can add for read and write. That's great. The second box where you set up security for your SNMP here. This is a good option for security because Windows doesn't support SNMP version 3. You can lock it down to only accept SNMP packet and send SNMP trap to a specific IP addresses. Here we'll specify NMS or Network Management System. And apply. And the next thing we're going to configure is trap tab here. This is where you enter in the information for the servers sending SNMP trap. Trap does not use community string that we added in security tab. Here, as you can see, they are not shown here. Obviously, it's for security issues. So again, we will specify SNMP trap here. And again, here we can specify the server, which is going to be our network monitoring tool, something like PRTG or App Manager, Zabbix, SolarWinds, or whatever. Okay, and apply. So this is how we can configure SNMP on Windows 2016, 2019. It's very easy. So you might ask me, what is this guy SNMP trap down here? Actually, this is for allowing the server that you're on to receive trap messages generated by local or remote simple management agent to force the messages to SNMP program on remote computers. And it's kind of like trap forwarder. So that's how to install and configure SNMP on Windows Server 2019. And now we're going to configure SNMP on Cisco switch or router. Simply we'll go to configuration terminal and we'll type SNMP server and question mark. So as you can see, there is a lot to configure for SNMP. And we're not going to cover all of these. We only want to talk about community string. Community and again question mark. Here you should type a word, which is going to be your community, which is like a password. As I said before, community string is like a password. But unfortunately, for less than version 3 is clear text on the wire. So let's say lab.ro and again question mark. Here it tells you want to use it as a read only, read write, or view, which is for version 3 of SNMP. So we're going to use RO, which is read only access to this community string, and RW for read write access to this community string. That's great. And RO. That's okay. And again question mark. So as you can see, we can specify accesses for security, something like that we done in our Windows Server 2019. We specified the IP address that only that community string can talk to that IP address. And it's highly recommend you, if you use SNMP version 2 or 1, you should specify the access list for the security issues. So here we will type the access list 15. And the second, we should specify the access list. List 15. Only we will specify the IP address that we want, which is going to be our PRTG server. Sorry, I forgot the permit. The full command is going to be like that. As it tells you that this is duplicated. That means we have this command already. So I can show you do show run include SNMP. Here you can see the full command for SNMP in this Cisco device. And again, access list is going to be only permit this IP address. Great. And again, we can specify SNMP contact, SNMP server contact, which is going to be my name, or SNMP location, somewhere in the Google Cloud. Great. And again, we have another great command, SNMP server if index persists. What this does, this allows these interface indexes to stay the same cross reboots. In theory, if you add or remove interfaces to a SNMP capable device, it could change the SNMP interface ID or interface index and throw off all of your SNMP manager statistics if they're not intelligent enough to realize these devices completely changed. Something like used to be serial port and now is MPLS port, unless you remember to change it yourself. Now we move on and implement SNMP v3 on the Cisco iOS platform. We're going to go more in depth with SNMP views and the different type of SNMP security available to us on the iOS platform. The first thing we're going to do is use some of the SNMP MIP views. So first, we'll go to global configuration. And we'll say SNMP server view, and we'll hit question mark. We should type a word for name of the view. Let's say normal. And again, question mark. And now we should specify MIP view family name, which is going to be ISO. And here we'll say included. And we'll hit enter. So this is not a required step unless you're going to restrict the view. If you don't specify SNMP view by default, the SNMP v3 user can see everything. So let's create a SNMP restricted view. So we'll type SNMP server view restricted. And we'll hit question mark. In this case, we will say it can only access the system information such as the system name and location and etc., but cannot access any other information about the host. Next, we should specify SNMP v3 permission. And we have to create a group to find these MIP views too. So SNMP server group, we'll give it the name monitor, and here we'll specify the version, which is v3. And now we get into the security level for SNMP v3. We have the auth security level, which corresponds to the auth no creep security level with SNMP v3, and this requires a valid username and password. But there is no privacy or encryption across the wire. Then we have the priv group in Cisco, which corresponds to the auth priv security level and SNMP v3. This requires authentication and privacy. So it does both authentication and encrypts the data across the wire. Then finally, we have the no auth group, which is no auth, no priv security level in SNMP v3. This essentially requires no username and no password. no encryption, it goes cross the wire. Actually turns SNMP v3 into a SNMP v2. So for our demo, we will use the auth group. So we'll say auth, and again question mark, and we'll say read, again question mark, read view name, which is going to be normal, and again question mark, we'll say write view for the group, the last one, write again for the group normal, and we'll hit enter. Now finally we move on to configuring the SNMP v3 user. So SNMP server user will say normal, and the group the user belongs again is going to be normal, which we specified here. And again question mark will say v3, again we should use the encryption level, and again we'll use auth and question mark. And now we have the option for MD5 or SHA algorithm. We use SHA because it is the little more globally supported, and again question mark, and here we need the password for the user. In this case we will say password, and again we can specify the private, but we use auth, we do not configure private encryption. That's great. This time we will hit enter, and last we will specify server trap. So we'll say SNMP server enable traps and enter. So once we tell the router which traps we want to send, we have to tell router where to send these traps. We'll say SNMP server host (192.168.10.225). This is our PRTG NMS or network monitoring system. And we'll say version 2. And again question mark. Here we should type the community for SNMP. Let's say traps only. And we'll hit enter. So even we can specify what class of traps to send in. We just want to send everything. So we'll hit enter as it shown before. And that tells to send all traps that are generated on this host to 192.168.10.225 using the community string traps only. Now is the time to move on and enable SNMP on ESXi and vCenter server. So to configure SNMP on ESXi, we need to enable SSH on ESXi to add a specific command for SNMP configuration. So we'll log into our ESXi and we will enable troubleshooting option for SSH. We'll press enter to enable SSH and shell. That's okay. As you can see, now is enabled. So now is the time to connect to this ESXi with PuTTY. So we'll double click on PuTTY and we'll connect to this ESXi, which is going to be 192.168.10.100. Root and the password. So there is two notepad here. The first one, how to enable SNMP on ESXi. So there is 3 commands here that we can enable SNMP on ESXi. The first one is going to be ESXi system SNMP set community, and this is going to be our community. Very clear. We can copy and here we'll paste it. So again, ESXi CLI, which is the utility that helps us to enable some component on ESXi or services, and system SNMP set, and this is going to be communities. And after this community word, anything that we will write is going to be our community string on ESXi, which in our case, I'm going to use ESX for our community here. We'll press enter, and the second one. This command is going to be enable SNMP on this host server. And the last one, we will restart the SNMP service on this host. We will wait for a second to see the result. As you can see, the last one is tells you that SNMP watchdog for SNMP started. And it tells you have to open the firewall for notification. That's okay. This is how we can enable SNMP on ES6i. And I'm using 6.7 ES6i in this demonstration. So now is the time to move on and enable SNMP on vCenter server. So here is our vCenter server. At the first time, we should actually connect to our vCenter server. So this is our vCenter server virtual machine. As you can see here, you should use F2 to customize the system. We'll type the password. And again, on troubleshooting mode option, we'll enable SSH, like we done before for ES6i. That's okay. And this is going to be our vCenter server IP address, root, and the password. Great. Now we should use the second notepad here for enabling SNMP on vCenter server. At the first time, we should use snmp.test to see if it's running or not. And it tells you that it's not running. So SNMP get. As you can see, the enable is false, which is not enabled. That's okay. So snmp.set communities vCenter. So for vCenter server, we will use vCenter word for our community to enabling SNMP on our vCenter server. You can use whatever community that you need in your environment. And here it tells you the host for community string. This command is for security issue. That means only respond to this IP address, which is going to be our PRTG network management station with this community. Again, we'll hit enter and we'll enable SNMP set log level for warning. And now is the time to enable SNMP. That's great. So again, snmp.test. Now is the time, as you can see, is true. The last one, it was false. Before we configure SNMP, it was false. When you enable it, as you can see, the result is going to be true and it can send the traffic to the target. That's great. Again, SNMP get. Now we can see the IP address and the information for our vCenter server. So now is the time to configure SNMP on Linux OS. So we'll do sudo apt-get install SNMP snmpd. And once I enter the correct password, it tells me I'm going to download all of these modules and everything. And do you wish to continue? So we'll say yes to continue. Give it a few minutes to actually download and unpack the modules. And like so, it's installed. And once it's complete, we can edit the configuration file. So we will do sudo nano, which is the built-in editor for Debian, etc snmp snmp.conf, and we'll hit enter. So now there is a lot you can configure in this file. Most of the default will work perfectly well. But there are some things that you need to change in order to make it accessible externally. First, if you look at here at the agent address section, you'll notice that it's configured to only allow access from the local host and not from the network. In this case, we're going to comment this out and we'll uncomment this line so that it will listen on all addresses on UDP 161. And all IPv6 addresses, even though we're not running IPv6 in our lab. And obviously, there is really not that much more to configure. We can look at some of the other options in here. Here is the option for SNMP v3 authentication, which it even tells you in this file they should be copied to a different configuration file. And changing the password. Further down, you have access control for SNMP v3. And this is all the part of the file where you would configure SNMP v3 MID views. So that specific SNMP v3 users can only see the part of the MID that you allow them to. For example, if you work for a service provider, you may put a managed router at the client side and you may allow them SNMP access to view, for example, the CPU and the memory utilization of the router. You may allow them to look at the interface configuration and the interface statistics, but you may not necessarily want them downloading the entire running configuration or dumping the route table out of your router because it could contain private information. SNMP v3 is the only way to perform that privacy, because SNMP v2 again just allows access to anything in the MID if you have the correct password. It's been my experience that MID views makes a little more sense when trying implement on a Cisco router. So for the rest of this configuration file, we can scroll down through it and we can see that we can limit the IP address range that can talk to this particular agent just like Windows. And further down we get to the system information including the sys location and the sys contact. We'll see these values again when we implement the network management system later on in the course. You'd obviously want to customize this, but I'm going to leave them like they are. And then further down you'll get into the process monitoring, which honestly is Linux specific and not SNMP specific. All of the defaults generally works pretty well. Once this is done, we'll save the file and then to reload the configuration file, we'll do sudo etc init.d snmpd restart. And it restarts and loads our new configuration. So this is how to install and configure SNMP on Linux distributions. Now here we are on Windows Server 2019 for installing PRTG network monitoring tool. Here you can see I already installed Windows Server 2019 data center version, and you can install it on a standard edition. Here we have free to download, you can download it and you have unlimited version of PRTG for 30 days. That's great for practicing this course with the trial version, and we have 30 days that we can practice the whole course with this 30 days unlimited version of PRTG. And after 13 days it reverts to free version. That's great. Here in product, download PRTG, or you can click on free download to download PRTG. So that's great. So it will point you to your license name and the license key. This is the trial for 30 days accessing PRTG on your lab or your production environment. And we'll click on download PRTG. So we will wait for finish downloading PRTG software. So when we finish download PRTG software, we'll go to download folder. We'll select the language. You can select whatever language that you want. And here we'll accept the terms agreement and next. And here's we need the email address for installing PRTG. You can add a group of emails here for receiving notification. Next, actually it's contact PressAllow license server to check the free license that is available or not. And as you can see, it checked the license and it's continued to install the software. It takes about less than 5 minutes to install PRTG with embedded SQL server that you can easily install it on your production environment. Now as you can see, we finished installing PRTG. Let's block sending notification for the first time. And this guide will tell you how you can change the password or accessing SSL encryption for PRTG monitoring tool. At the first time, PRTG added the sensor for probe device, which is PRTG server. And it will scan your subnet here and discover those servers. And it will add at least ping sensor to discover availability for that servers or whatever devices. That's great. So after done installation, we should fix these two notifications. Set a secure password. We'll click on change default password. Of course, you can go to setup and in your account and my account and change the password. That's great. And here we'll specify new password. The old password, which is going to be the same with username. So we'll change the password and confirm it. Let's close this box to see the save button here. And again, we can enable SSL encryption for the PRTG website here. And here we'll hit save. That's great. The password has been changed. So as you can see, we have the latest version, which is 19.4.53. This is the latest version that you can install. We'll click on install to download the latest version. It takes time actually to download the latest version. And if you want to use PRTG on internet, I strongly recommend you that you use SSL certificate for accessing this PRTG monitoring tool from the internet. So we'll go to setup and system administrator, user interface. We'll scroll down to web server and here we'll select secure HTTPS server recommended mandatory for internet access. And you can use the security method here, high security TLS or TLS version 1.2 or weekend security. The default one is going to be a good option. And here it tells you you will be disconnected for a few minutes. We'll click on OK. So as you can see, we can access our PRTG server by HTTPS, which is security socket layer. We'll click on advanced and process to the unsafe version. And now you can use your SSL certificate to install it on your PRTG server to actually security and accessing your PRTG server from the internet. So we'll wait for PRTG server to initiate its probe device here. So here we can see the sensor back again with HTTP access. And in today's lesson, we learned how we can install PRTG network monitoring tool. Thanks for watching. So now that we've installed PRTG network monitoring server, let's go and configure Windows Server 2019 by SNMP and WMI. So manually we'll go to server under Windows and add a server. And let's say server 2019. And we'll type the IP address. And here we can specify which icon that you want. Let's say this one or this one. And for device identification, let's say a standard auto discovery, which is recommended. And here we can specify the schedule, once, hourly, daily, or weekly. If you have a device, say that has a lot of disks that come in and out, you could rediscover every so often. For example, daily or weekly. And now is the time to configure WMI, which is Windows credential. And we can configure Windows system credential in root level. But this time, we want to do it manually. Again, in root level, you can configure your domain credential for all of your Windows servers. We can specify the domain, something like here, and domain admin credential here. That you can specify it for all of your servers. But we don't have domain in this example. Let's say our server, which is server 2019, and the username, which is the local, and the password. So for the first time, we'll configure it without SNMP to see what will happen. And let's say OK. As you can see, the server rediscovered the sensors. So we will wait for the sensor to be added here. So as you can see, our sensor is added here. This is how you can configure WMI in Windows Server. Great. You can check out CPU load, which is 2%. There is nothing going on in this server, just for our lab. And again here, the uptime. And disk free space here. So now is the time to add sensor that work with only SNMP. So we will add a sensor, and again disk usage, Windows, and SNMP. We can see SNMP disk free, and we'll add it here. As you can see, this scan has failed because of the error with SNMP. It tells you that no response, check firewall routing SNMP setting for device. As you can see, is clearly for community string of SNMP. So that's great. We will back again to device, and here in servers we'll hit setting and we'll configure SNMP here. Let's say lab.ro. We'll save it here. And again, we'll add that sensor. Disk for Windows by SNMP. And we'll add it. As you can see, it discovered C partition of that server. Great. And again, we add another sensor, which is going to be CPU for Windows, and again SNMP. We'll add SNMP CPU load. We have the sensor CPU load for WMI, but this is something different, which is SNMP CPU load. Is only forked with SNMP. And there is nothing to configure here, and we'll add it. And again, we will add this time memory usage for Windows and by SNMP, and we'll add it here, and we'll select all of the virtual memory and physical memory. Great. And down here you can see the new sensors here. It takes time actually to pulling that sensors. Let's say scan now. As you can see here, you can see that the SNMP CPU load here. With the pop-up that shows you the real graph monitoring, which is very great option in PRTG network monitoring. So we need to configure SNMP for devices something like Cisco routers or switches or storage. This is the only word of SNMP for that device. But for Windows, you can use WMI, or for Linux, you can use the root password. And the reason why you configure SNMP and set up a network monitoring system is, for example, you want to know before your users tell you if a device goes down or if the server running out of disk space. It makes IT in general look a lot better whenever users call up and say, hey, my phone just went down. And it will be great if you can respond, yeah, we know one of our switches just went down. And it will back up again in a few minutes. That's the reason why we should think of network monitoring tool. Now is the time to configure SNMP of a Cisco iOS device. And we'll add Cisco switch to PRTG by SNMP. So here, simply we'll add the device on Cisco switch group. By default, you don't have Cisco switch group here. Basically, you can add the group here in management and we'll click on plus and add the group. Here we'll specify the parent for that group. For example, on network discovery, and we will hit OK. And here we will type the name of the group, the tags, and again the SNMP credential and the rest of information here. The great option here, you can specify SNMP for group of Cisco devices here. That means at the same time you can discover all of your switches in your environment. That's a great option, and you can rediscover all of your switches at the same time. But in this demo, we're going to actually add it manually here. Let's call it switch 01, the IP address, and we'll specify the icon here, which is going to be Cisco device. And for auto discovery, we'll leave it default, which is no auto discovery. And for SNMP, we'll specify the SNMP. Great. And we'll hit OK. Now, as you can see, we have switch 01 here. And here we can specify the recommended sensor for that device simply by clicking on recommended now. OK. And we'll wait for those sensors to be added here. Now, as you can see, is added ping sensor and 5 more sensor, which is going to be uptime, SNMP traffic, and so on. We'll add this sensor, OK, and ping sensor again. And again here, we'll click on scan now. Takes time actually to pull in that sensor. So as you can see, all of our sensor is added successfully. And this is the traffic sensor for specified Cisco interface devices here. And the uptime here, as you can see, the sensor and the channel. And again, for traffic here, we can see the channel's configuration here. Traffic in, traffic out, and the total traffic and unicast and the rest of information. Great. And again here we can add a sensor for a specified switch. Let's say network infrastructure, SNMP, and we'll add trap receiver here for that switch. And again, we will use a scan now. Here we can see the sensor is added again. So in today's lesson, we learned how we can add our Cisco devices by using our SNMP protocol. Now is the time to move on and add our ES6i and vCenter to network monitoring system. Here simply, under virtual systems, VMware, we will add VMware hosts. We'll add the device and let's call it ES6. And the IP address is going to be 1000 and we'll select this icon, which is VMware. And here we'll specify credential for VMware and Xen server. So before we go on and monitoring SNMP protocol on ES6i, I want to show you how we can monitor VMware ES6i with root credential. So here we'll say root and the password. There are great sensors that you can monitor with VMware credential here. And we'll hit OK. And here, as you can see, this is the ES6. We'll add a sensor and we'll select Virtualization OS. And we'll scroll down to see VMware Data Store here. We'll add it, that you can monitor ES6i data center with this sensor. As you can see, we'll select 2 data stores that connected to this ES6i. Again, we'll add another sensor for virtualization. Scroll down to see VMware Virtual Machine. This sensor actually helps us to monitor all of virtual machine inside our virtualization platform or ES6i. And here we will click Scan Now. So as you can see, we have these sensors here. This for data store. You can monitor your data store, the capacity, the free space, which is a great option here without configuring SNMP. And here you can see VCSA virtual machine, which is vCenter Server Appliance Mode. And this is going to be our DC1. Here you can see the active memory, data store, total, write left empty, and the rest of information, network receive and usage, and so on. Great. Now we want to actually add CPU for SNMP, CPU load. So here, SNMP CPU load, we'll add it and create, and again we'll add another one for memory SNMP. Here we'll select SNMP memory, this sensor. Now we should see the error that SNMP is not configured in your device. As you can see, the error here. So we'll get back to the device. Now we'll scroll down to configure SNMP for this device, which is going to be ES6i. So the SNMP community is going to be ES6. And we'll save it. And we'll wait a second to see what will happen. So in the meanwhile, we'll click on Scan Now. As you can see, SNMP CPU load is now working. And we will add another sensor, which is going to be the memory, that we get the error. So as you can see, the memory is now green and OK. So for ES6i, we have the ability to actually connect to ES6i with the root password, and you can use these sensors, data stores and virtual machine statistics. But if you want to monitor CPU load, memory, interface statistics, or whatever that you can see that you cannot monitor it with the root password of ES6i, you need to configure SNMP for ES6i. Keep in mind that. So again, we will add our vCenter server here. Let's call it VCSA. And the IP address. And we'll select this icon, which is Linux icon. And this time, of course, we can select the credential, which is going to be root and password of vCenter server, but We only want to actually add our SNMP community here. And this time we will select Linux. And we scroll down to see SNMP CPU load. And we'll hit create. And again, Linux. We will scroll down again to see Linux uptime. SNMP system uptime. Or again, we can add trap receiver, which is going to be great sensor for vCenter server. And we'll click on scan now. So now, as you can see in this demo, we learned how we can add our ES6i and vCenter server by SNMP protocol. So now that we set up our network server for network management, let's go ahead and configure our network management system. PRTG has the concept of inheritance, where you define certain settings at the root, and you can have different groups that may inherit those settings or may not inherit those settings. For our purpose, they are all going to pretty much have the same setting, because all we're doing is SNMP and there's only few devices. So we'll go ahead and click on the root. And again, every system is different, but with PRTG, you can go ahead and change the setting right here at the root, and it will flow down to everyone else. So we'll go ahead and configure our SNMP community string. We'll also go ahead and configure our credential for Linux system, just so we can get more details information. So we'll go ahead and give it this username and password here, like so, and we'll also go down further and change the credential for SNMP devices. Now this is where you can choose the SNMP version, at least with PRTG. There are some limitations to SNMP v3 if you have a very large network. We're going to keep things simple and just do SNMP v2 polling, because the concepts are the same when you're talking about a new management system. So we'll go ahead and change our community string to globo-ro, which is our read-only string. And you see, if we scroll down, we have credentials for database management and Amazon, MQTT, and we have SNMP compatibility options. Now for most of us, the default value will work just perfectly. You always want to make sure you use a 64-bit counter, especially if you're using SNMP v2. But otherwise, the default work fine. We have proxy setting and the scanning intervals, which is every 60 seconds. And if the query fails, what do we want to do? We set it to warning for one interval, which is 60 seconds. And then set it to down if it doesn't come back. That's all we pretty much want to change here. We'll go ahead and click save. So now that we've set the system defaults, let's go ahead and see if we can configure our Linux box. So we'll scroll down here to the Linux, Mac OS, Unix, and I've already done the discovery, and it recommends adding these two sensors. We'll get the ping and the uptime through SNMP. We'll go ahead and add the disks and the memory and CPU information, so we'll add them all. Now the sensors are where the rubbers meet the road. That's where you can get more information other than just the ping time and the uptime. Depending upon the device, you can get all kinds of information. Like Windows devices can tell you what services are running or not running. You can get information about disk access and etc. And all of that through SNMP, you might have to use WMI to get that. But we'll talk about WMI when we go to a Windows server. We at least touch on it because it's generally related to SNMP, as it's still a network management protocol. While we're waiting for those sensors to be added, we'll go ahead and look at these system information for an example. And you will see here for the contact info and the location, you remember that setting from when we configured our Linux box setting on the dock of the bay. So it shows that we now have the correct SNMP information. So now we just have to wait for it to finish configuration everything. We've got a lot of errors on here just because it's not been fully set up in the system yet. So I'll go back to overview and see if it's added those sensors yet. And here we are, as you can see, disk free, inodes free, load average and mem info. So if you look at the load average as an example, you will see that at 0 because it's just now started scanning 47 seconds ago. So now we're going to take a few minutes to talk about some of the do's and don'ts of network monitoring in general. Now I know this is a course on SNMP, but I wanted to kind of back up and give you a broad overview of what SNMP is used for. Obviously, it's a network management protocol, and so the whole reason you're going to implement SNMP is to manage a network. And what good is managing a network if you don't have a network management and monitoring solution in place? So that's the reason we're taking a bit of a step back to kind of give you a holistic view of what you will use SNMP for. The first thing I can recommend is ensure that all of your devices are monitored. And again, this kind of sounds like no-brainer. Well, of course I want to monitor all of my devices, but you'd be surprised at the number of places that I see where they only monitor their core servers and core switches and routers in their branches. Well, what about the switches that on your branches? They said, oh, those aren't actually important and we don't waste time monitoring them. And you can probably get away with that until you have a bad QoS policy in one of your switches, something like CPU with 100%, and impact traffic flow or voice traffic to those devices connected to the switch. The same goes for infrastructure devices such as fiber channel switches or SAN storage that most certainly have SNMP monitoring ability built into them. You want to know everything about those devices that you can. In short, if it speaks SNMP or you can somehow get manageability that speaks SNMP to that device, you probably want to monitor at least some of the outposts, if nothing else than uptime and CPU. Of course, this gets into a bit of cost because nearly every network monitoring system out there prices their product per device. But in the long term, it will pay for itself because you get very detailed views into everything that's going on your network. The second is set realistic alert threshold. When you first set up a network monitoring system, you're going to get flooded with alerts and potentially with emails about every little thing that happens on your network. Something like, this particular device's CPU is over 10% for more than 2 minutes. This device has a high ping time for the last 30 seconds and etc. And it's tempting to just take all of those alerts and say, I want to know about everything that happened. And then you will get these alerts and you get these emails. And you open up your email and look into the folder and there is 2,000 unread emails on your alert folder. What do most people do when they see that? They go in there, that highlight everything, and they hit delete. You run into a problem of having too much signal to noise and potentially missing something important, and it's kind of, a hairy thing to get into. Because where are those alert thresholds? What we can get actual actionable alert out of the system. And honestly, that's different for every environment. You will have to run it in kind of verbose mode for a while before you realize that, oh yeah, these bandwidth alert that I'm getting every few minutes because of the bandwidth spikes or from backup being taken or our SQL server. So I don't necessarily need to know about those on this particular server. Or I need to set the threshold higher, so that if it goes on for 15 minutes, then I know about it. So at the end of the day, if you're responsible for network and infrastructure monitor, it will take some buy-in from all of the other departments that manage SQL server and image server and etc. If that doesn't happen to be you, to find out where these alerts need to be set and getting those alerts to the appropriate person or group effectively. Lastly, check the report. Again, kind of no-brainer, but especially after a while, you start getting those daily report or weekly reports about things that have gone on the network. Here's the bandwidth has been used, here is the latency, here is the disk space, and you will see those reports. You go, oh yeah, there is the daily report, and again delete. And you do that enough, and then you start getting phone calls saying, hey, I can't connect to my email database, and you go and find out that the Exchange service are not running, or the database is filled up and you can't write any more data into your Exchange database. And you might ask yourself, why didn't I know about this? And this goes back to the last two bullet points here. You need to make sure that your alert threshold are set, such that you'll actually read and take action on and the alert that you'll get. And if you're getting reports on disk space or things like that, actually read those reports that you took the time to build and have emailed to you. Your network monitoring system is only as good as you make it. And there is no point in enabling SNMP on all these devices, setting up SNMP v3, the encryption, making sure that you have encryption lockdown, setting up a network monitoring system, making sure that is polling everything properly, which is a lot of work, and then just ignoring the output of that system. It just makes no sense, but you'd be surprised with the number of organizations that do exactly that. And that concludes our discussion on network monitoring. So now we're going to move on and talk about troubleshooting using SNMP. In this section, we're going to troubleshooting an issue with the network management system, not an issue with the system itself. But troubleshooting network is you using the network management system, and then we'll end the course with the brief discussion on monitoring itself. Some of the do's and don'ts, and that I'll discuss over the last few years of doing network monitoring. Some of the items are pretty much common, but you'd be surprised how many people just don't put the kind of critical thinking into setting up their network monitoring system. So we as the network administrator have just gotten a phone call. Is one of those wonderful phone calls, very non-specific, and says, hey, the computer seems to be kind of slow. Can you check things out and see what might be going? And we all love getting those calls. It could be anything from software running on that workstation or a problem with the specific server or WAN connection. Well, if we have proper network monitoring in place, then this is a lot easier to troubleshoot. So the first things we do is we go into our network management console. We already see that there are two alarms. We could look at those alarms, and that will give us a clue as to where to start looking. So we'll view all the alarms, and right now there is only the SSL certificate sensor of our routers. So that's not really going to help us. The next thing we can do is check out the devices on the network. So we'll go look at our device lists here. Everything still appears to be in the green all the way down, except of course with that lovely SSL certificate. So let's have a look at the server itself. So we'll go to Globo-SRv1. The ping time looks okay and the CPU load looks okay. These graphs down here, the Ethernet traffic says it looks like it's pushing 62 megabits, which you know obviously is quite a bit. You see that it's all inbound traffic depending upon the normal traffic loads. And what's actually going on that server could be normal, it could be not. And the only reason that the network management software hasn't flagged it as being outside of the baseline, because I've honestly just started the traffic a little bit ago. I'm using a product called iPref that generates traffic, and I'm pushing 6 megabits of traffic over that server. I could very easily do 600 megabits since it is a gigabit adapter that connected. And we could watch the sensor here in just a moment after it takes some time to pull. But we'll notice that even after running for a couple of minutes, we could go back here and see that it's been running for about 5 minutes actually. We still aren't getting the value that we expect here. We're still only showing about 48 megabits, which obviously is not correct. The reason for this is because this particular poller is polling a 32-bit value. You see right here under sensor type where it says SNMP traffic 32-bit, and what's happening is the counter rolling over. And the network monitoring software is translating that as a lower amount than it actually is. This is why I always recommend using a 64-bit counter if it's available. This one is just what happens to be built into PRTG for SNMP. Now if we go back and we add the WMI poller on the same server, I bet you will get the correct information. So we'll hit add sensor and we'll say we want to do traffic on Windows box, and we'll add Windows traffic card. And after just a moment, we presented with the only actual valid network adapter on the host, which is the Microsoft Hyper-V network adapter. With SNMP, you get a lot more information, just as we saw earlier on when we were using the SNMP walk tool. And we'll see all of the different interfaces. However, WMI, which is what is particular polling is using, is a lot more specific. So we'll go ahead and create this guy, and we have two different network monitoring down here. So we'll wait a couple of minutes for it to actually get kicked off and start collecting data. And once it does, we see that we're getting the proper reading from this guy, 626,000 kilobits per second. We'll click on this guy down here to see its bandwidth utilization, and you'll notice that since we're using WMI, we're getting a lot more information on Windows Server. Now we can absolutely get this information from SNMP, specifically on networking devices. But in order to do that, you'd have to set up a custom poller or a custom probe in the PRTG. And that's a little bit outside the scope of this particular course. You can watch my PRTG network monitoring course, since that's specific to the network management system and not to SNMP or network monitoring in general. But getting back to troubleshooting, we would see that this server is polling 600 megabits. There is probably something wrong with the server, and we would be prompted then to go look at the server itself. Of course, we causing this problem using this performance tool here. So if we hit Ctrl C and exit it, we'll see that it goes back down to practically nothing here very soon. Thanks for taking my course, and I want to encourage you to take a moment to connect with me on LinkedIn. I have included a link to my LinkedIn page on the course resources for this video. LinkedIn is a great way to hear about new courses that I'm releasing or to reach out and ask me questions if you want to stay connected. So please take a moment to go over to my LinkedIn page and connect with me so that we can stay in touch after you've completed this course. And you can always ask questions if you like or request discount code for my other Udemy courses. And here is my website, which we have product and courses and membership. Let me introduce you to the product. Here we have EveNG full pack image, and of course GNS3, which I'm going to talk about it in a second ago. And here EveNG full pack images, you don't need to install EveNG, you don't need to upload or convert the images, you don't need to have the knowledge of working with EveNG. All you have to do is to buy this product and import it as an OVA into your VMware workstation or ES6i, and of course your Google Cloud Platform account, and you can start practicing your CCNA, CCNP and CCIE labs without any wasting your time to configuring EveNG full pack, and no need to extra effort. And here, as you can see, there is a video instruction how you can install it on ES6i on VMware workstation. And this is the instructor, and these are the images that included with this product. I mean, when you install this product EveNG full pack, you're going to see all the images already installed on your EveNG, and it is going to be ready for you to start your lab without wasting your time. Less than an hour, you will see you will have the EveNG full pack already installed with all images that you can see right here. And of course, here you could have the EveNG collection lab. They are pre-built EveNG labs that you can practice your CCNA, CCNP, and CCIE. And if you don't have PayPal account, don't worry. PayPal payment is going to accept your credit card, which is the new feature in the PayPal account. And here, of course, we will have another product, which is again a great product, which is GNS3 and EveNG images collection. Here you can see that we have the video instructor how you can import these images into your GNS3 and of course into your EveNG here. And again, here we have collection labs, you can download them, and again you can pay with your credit card and PayPal account. And here you can see the images. Once you buy this product, I mean EveNG collection images, you will have access to this website, and here you can download the images for Dynamics, IOL here, and of course Chemo files here, as you can see. Here you can find the QCOF tool with the RAR files, ACS 5.8 here, and of course Arista and Cisco Endpoint CSR 1000 here, as you can see. And this is SD1 router with this build number here, and as you can see they are already converted images that you can easily upload it to your EveNG, and you don't need to waste your time to convert them, and you can easily just upload them and start practicing with these images, like the video instructor in the page product that you can watch and see how you can easily upload these images, which is again here we have F5, the latest version, and Viptela, as you can see SD-WAN here. These are the new images, and as you can see there are a lot of images that you can use in your EveNG or GNS3. And again here you have the collection images, you can download them here, and these are the pre-built collection labs that you can easily import them into your EveNG. And let's get back to our website here. Again, here we have the courses. You can enroll in my courses. The great thing about my courses is you will have the membership here. These are the courses, around 10 courses by now, and I'm going to add new courses. We have a lifetime access here, which is very cheap. You can purchase this bundle and you will have access to all current courses and of course the future courses that I'm going to release in my website. And one thing is very important, you will have the great support even in LinkedIn for my courses, and of course in the chat box here you can ask question about the course, or if you have a question about the lessons, here you can connect with me in this chat box. Or of course you can buy the course individually here by going to each courses, and you can buy this course, for example SolarWinds, and with this price you can have full access to the SolarWinds NPM training course, which included 7 hours video and of course the unpublished ebook from me. I'm going to publish this book in future, but you will have it for free once you pay for this course, and the rest of them, as you can see, we can give you the remote support by TeamViewer, and all the courses like Udemy, they have installation file like Windows or something like application or SQL Server or things like that.